Greetings everyone, we will continue our discussion on programming for problem solving using C. In the previous session we have started about what are arrays and we have seen the various types of arrays, that is one-dimensional array, two-dimensional arrays and multi-dimensional arrays. In this session we will be looking about the applications of arrays and also a related topic called as bounds checking. So what are the applications of arrays, that is how you can use these whatever one-dimensional, two-dimensional or multi-dimensional arrays to perform various applications. So the various applications you can perform are, the first thing, to store a list of values. You can use the one-dimensional arrays to store a list of values, or you can use other dimensional arrays to store the values in your arrays. The second thing, to perform various matrix operations. I think you know various matrix operations you can perform. You should be able to perform matrix addition, matrix subtraction, matrix multiplication and other matrix operations, transpose, diagonal element search, each and everything you can perform by using your arrays. The third application is you can be able to perform search operations, that is you will be able to implement search algorithms. You will be having some search algorithms and you can be performing sorting algorithms, that is you can sort your values either in ascending order and descending order. And the last, you can perform something called as frequency arrays and histograms, that is you can implement frequency arrays and histograms. So we will try to discuss all these particular applications and how you can implement them. So we will be looking about them one by one. So the first thing is you should be able to store a list of values. If you remember properly, you have already discussed about one-dimensional and two-dimensional arrays. As a part of those implementations, I think you remember you will be having your one-dimensional arrays which will be present in a set of indices, and you will be storing values in those particular one-dimensional arrays. So as you can see, you are storing the values in these particular elements. In the definition itself, you should remember they will be stored consecutively one by one in the memory. That is, these elements will be present consecutively in the memory one by one. So this is how you will be able to store the elements. And in the same case with your two-dimensional arrays. So if you take a two-dimensional array, let's take a 2 by 3 array. That is, if you take a 2 by 3 matrix, you will be having 2, 3, 4, 5, 6. These are the values which are present in a two-dimensional array. So the two-dimensional arrays will be stored in your memory in this manner. So I think you remember the indices. This will be 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. So they can be stored in two different ways. So the first element, that is the first row values, will be stored like this: 1, 2, 3, 4, 5, 6. So they will be stored in the memory locations in this manner. That is, first row elements, after that second row elements, after the third row elements. This will be calling it as a row measure order. Many of the systems and your C language uses this row measure order, where you will be taking the first row elements and storing it in the memory, and the second row elements and storing it in the memory. Like that you will be able to store all the elements present in the matrix or your two-dimensional array. There is another method where you will be using the columns, that is the second method is column measure order. So where you will be storing the first column first, then the second column, that is 2, 5, then the third column 3, 6. This will be calling it as the column measure order. This will be calling it as a row measure order. So you can store these two-dimensional elements in your particular memory in this manner. Either you can use the row measure order or you can be using the column measure order. Most of the systems use the row measure order to store your particular elements. So whatever may be your dimension of your particular array, you can remember that, or you can be assured that most of these arrays, whatever you are having, will be used to store a list of values. So you will be using the one-dimensional array to store the list of values. You will be using your two-dimensional array to store the list of values, whatever you are having. So anywhere you will be storing the list of values. So if you remember, in order to store the list of values, you have to take the input from your keyboard or other general purpose. So you should be knowing how to declare an array, that is, it might be any size, any dimension of your array, and you should be able to give input for those values, that is, for I is equal to 0, I less than 3, I plus plus, for j is equal to 0, j less than 4, j plus plus. So A of I. So whatever may be your complete thing, this will be able to take the input from the user and it will store the values into the particular array A. So each and every program will be having the minimum declaration of your array and taking values into that array. Okay, so that will be the storing the list of values. Okay, once after storing the list of values, you should be able to perform whatever operation which is provided. So the second application you can perform by using your arrays is matrix operations. So you can perform matrix addition, subtraction, transpose, rank. Like this you can perform any number of matrix operations. So I will be giving you just an example about matrix addition now, how to perform matrix addition in your C language. In future you should be able to write the programs for the remaining, you should be able to write programs for subtraction, transpose and multiplication and other matrix operations. The basic thing is you should be able to use this particular part, that is how to use your two-dimensional arrays to perform all these operations. So in order to perform the matrix addition, so I think I will take it like this, that is I will be taking one A array, another B array, and I will storing the result in C array. That is, you have to declare 3 arrays. So I will take a 2 by 2 matrix and I need another B array, 2 by 2 matrices, and another C array, 2 by 2 matrix. Okay, this will be the declaration part, and you should know how to initialize, that is, you should know how to input those A array and B arrays, that is, you should be able to use the scanf for I is equal to 0, I less than 2, I plus plus, for j is equal to 0, j less than 2, j plus plus, scanf %d address of A I j. Okay, this is how you input values into the first array A. The same case you have to input B, that is you have to write the same code for your B, address of B I j. This is how in any program you should be able to input your values into the array. Once after giving values into the array, that is you have given values into the A matrix, you have given the values into the B matrix, now you should be able to sum these two values. That is, you will be having your A matrix, let's take values as 1, 2, 3, 4, and they will be having B matrix 5, 6, 7, 8. Okay, in order to perform the addition, what you should do is you have to, this will be the indices 1, 0, 1, 1, this will be 0, 0, 0, 1, 1, 0, 1, 1. So I think you remember in your matrix addition you have to add these two values, that is you have to add the same subscript values, that is you have to add 0, 0, 0, 1, 0, 1, 1, 0, 1, 0 and 1, 0, 1, 1 and 1, 1. What you have to do, you have to store it in a third matrix C. So you have to add 0, 0 and 0, 0 and store it in this particular 0, 0 position, and you have to add 0, 1, 0, 1 and store it in this 0, 1 position, and same is the case for 1, 0 and 1, 1. Okay, in order to perform, you will be using the same for loops. For I is equal to 0, I less than 2 rows, I plus plus, inner loop for the columns for j is equal to 0, j less than 2 columns, j plus plus. Okay, so what is the operation you have to do? C I j, that is C00 is equal to A00 plus B00. A I j plus B I j. So this is the process you have to do, that is, this is how you will be adding all the elements that are present in your matrices. That is, you will be performing the matrix addition, that is, you will be taking the matrix A, adding with matrix B and storing it in matrix C. When your I value is 0, j value is 0, A00 and B00 will be added and stored in C00. When I value is 0, j value is 1, C01 will be equal to A01 plus B01, that is 01 and this 01 will be added and stored in this 0. So we will be getting your 6, 8, 10 and your 12 value. So this is how we will be performing matrix addition. Once after performing matrix addition, you have to output this particular C result. That is, if you want to print the matrix addition result, what I have to do? I have to take the same for I is equal to 0, j is equal to 0 and print your particular C matrix. That is, you will be specifying printf percentage %d C I j. Okay, so that is how we will be printing all the values that are present in your C matrix to print your matrix addition. So you should be able to do one by one, that is, you should be able to declare, then you should be able to give values into that particular array. Then the process part, what is the process? Process is the important. Here you have to perform your matrix addition. So this is how you perform the matrix addition. And then the output part. What is the output you need? I need the addition output which is present in C. So I will be using the same for loops and the C matrix inside to print your complete C matrix. So this is about matrix addition. The same thing if I want to perform the matrix subtraction, place the minus symbols here. That is, I will be performing the matrix subtraction. So when you go for your matrix multiplication, it will be somewhat complex. If I want to perform the transpose of a matrix, what I have to do? I have to interchange I value and j value, that will be transpose of the matrix. So if your I value is 0 here, I have to get j value as 0. So if I take this particular j first and I first, I second, then I will be getting the transpose. Okay, in a similar manner you can be performing numerous applications for your matrices. So you should be able to work upon them, each and every matrix operation you should be able to work. These things will be used in your future applications very more. Okay, so this is about how to perform your matrix operations by using your arrays. So this is the second application you can perform. The third application is searching algorithms. You will be learning about the searching algorithms while you go for your data structures course. So we'll be having two searchings. One is, we'll be calling it as linear search, binary search. Okay, we'll be having linear search and binary search. What is the searching means? Suppose if you are having a one-dimensional array, 5, and if you are having value 10, 20, 16, 19, 23, 46. Okay, so searching means if I have something key. Okay, if I want to search some element 20, this will be the key. Whether this particular key element is present in this array or not. Whether this particular key element is present in this array or not, we will be calling it as search. Okay, whether the particular key element is present in this elements or not, we will be calling it as a search. A search can be done in various ways. One of the thing is linear search. I will try to describe the linear search here. You will be learning about those searching technologies in the next sessions, next semesters. So linear search means what will linearly. You are going to search linearly from starting of your array to the ending of the array. That is, First what you are going to do is you are going to take this key and compare with this element, that is whether key is equals to the 0th element or not. Then I am going to compare key with the first element, then I am compare key with second element, third element, fourth element, fifth element until the n elements. That is, you are going to start at the first element and go on up till the end elements. So you are going to search linearly from the starting of the positions to ending of the positions. That is why we will be calling it as linear search. Okay. So for this, how you are going to write the code? So for this, for I is equal to 0, I have to go until n. So I will be having 5 I plus plus. So I have to start from 0 position to the 5th position, and I have to compare my key element with this 0th element. If key is equals to a of I, if key is equals to a of I, that is first I am comparing key with a of 0, then a of 1, then a of 2, then a of 3. Like this I will be comparing with each and every element until the last element. If it is found, what I can print? Tell that it is a such successful. If no such successful is present, I can print it as not successful. So in this example, if I take the key value as 20, it will be present at the first position. I will be getting it as such successful. So I will start with the first position. I will go until the end of the last, and I will compare my key element with each and every individual element from 0 to n minus 1. If at any time if they are equal, then I can say that the search is successful. This is about searching implementation. So we'll be having this searching algorithms which you are going to learn in your data structures course. The next, you are having the next application is your sorting algorithms. Sorting algorithms means if you are having your array and they will be having some set of values. If you are having some random set of values, sorting means you have to take these values and make them into either ascending order or descending order. So most implementations will implement your ascending order, where if you are having these as the indices, so we will be having the result as 1, 2, 3, 5, 9 and 16. Okay, we will be having the indices as in this manner, that is 1, 2, 3, 5, 9 and 16. Okay, so taking your complete one-dimensional array or two-dimensional array and sorting all those set of values into either ascending order or descending order, will be calling it as sorting. You are going to have numerous sorting algorithms which you are going to learn in the future courses. You will be having many sorting algorithms like bubble sort, insertion sort, selection sort, merge sort. Okay, we will be having many such sorting algorithms which you are going to learn, but basic concept is you have to take the set of values and sort them in ascending order or descending order. That is about sorting algorithms. So your arrays will be used for performing this sorting algorithms also. The next is your frequency arrays. So what is this frequency arrays? If you are having an array A, and let's take these values, and if I take some set of values from 0 to 9, let's take 1, 2, 1, 3, 1, 1, 4, 1, 5. So these are your values that are present in your array A. Array A. So frequency array means if I take this array and find out the frequency of each and every digit that are present in your complete set. That is, I have taken this array from 0 to 9 only. If I take the values from 0 to 9, not these values, actual values that are present in your array. If I take these values from 0 to 9 only, okay, then how many times a particular digit is repeated. That is, how many times 1 is repeated, how many times 2 is repeated, how many times 3 is repeated, how many times 0 is repeated. Okay. Your frequency array, the new array, will be having positions from 0 to 9, that is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, your frequency array will be having positions from 0 to 9, and I have to count these values from 0 to 9, that is, if I am how many times 0 is present in this particular array. It is not present, so I will be replacing with 0. Then how many times 1 is repeated, that is 1, 2, 3, 4, 5 times it is present, so I am going to keep the frequency of 1 as 5. Then 2 is present once, 3 is present once, 4 is present once and 5 is present once. So 6, 7, 8, 9 is not present in your particular array. So this representation of the number of times a particular digit is repeated in an array, will be calling it as the frequency array. Okay, so this frequency array can be represented diagrammatically in your output. So for example, if I want to take the same thing, that is, as an output, if I want to print them like this. Okay, so I have to print 0 to 9 in this manner, and how many times a particular value is repeated. If it is present 0 times, I will not be writing anything. If it is present 5 times, I will be printing it as 5 stars. Then if it is repeated once, I will be printing it as 1 star. So 5 is repeated once, 1 star, and the remaining times it is not repeated. So this thing will be calling it as histogram. I think you can think a histogram as your bar graph like thing, where you will be representing them with stars here. So your arrays can be used to implement this part, like you can take the original array, from that original array you can create the frequency array. The frequency array is nothing but number of times the particular elements are repeated. From this frequency array you can create your histogram in this manner. Okay, this will be about writing the logic for your frequency arrays and histograms. So these are the various applications regarding your complete one-dimensional and two-dimensional, or more specifically arrays. So your arrays will be used to store the values first. The second, it can be used to represent your matrix operations, that is, it will be used to implement your matrix operations. It will be used to represent or implement your searching algorithms and implementing your sorting algorithms, and it also will be used to implement your frequency arrays and histograms. So these are the applications where you are going to use your arrays. And the last topic you are having as a part of this arrays is bounds checking. What is this bounds checking? Suppose I have declared an array with 3 elements. Okay, suppose I have declared an array with 3 elements, and let's initialize them. Directly if I initialize, p of 3 is equals to some 10, 20, 30. This is the initialization I have done. Now what happens? It will create an array with 3 elements with indices 0, 1, 2 and values 10, 20, 30, and this is the array A. So this is a declaration. Okay, according to the definition of your array, I told you this, the first index will be calling it as the lower bound. The first index will be calling it as the lower bound. The last index will be calling it as the upper bound. Okay. So that by the definition of your arrays, you will be having the particular indices for your first element and the last element. The first element index will be calling it as the lower bound, and the last element index will be calling it as the upper bound. So while writing the programs, for example, if I want to print the array, what I will be writing? For I is equal to 0. Okay, I have to start from 0 and end at 2. I less than or equals to 2 I plus plus. This is the thing I will be writing. So if I want to printf percentage d a of I, sorry, this is only one dimensional array, so I will be writing a of I. So this is how we will be writing to print all the elements in the array. So I am specifying the first bound, that is lower bound 0, that is I have to start from 0 and end at 2. So but the common mistake we might be doing is, since my array size is 3, most of us we specify the particular value as 3, I less than or equals to 3, or sometimes we start from 1 or we end at equals to 3. So when I write the program in this manner, that is I am starting from 0 and ending at 3. So now what happens? I am starting at 0 and I am ending at 3. So remember, as a part of the array, the last memory location is not part of your array. Your array is only from 0 to 2. But while writing the program, you have made a mistake that you have started from 0 and ended at 3. Okay. So your C language, what is the problem with the C language is, C language doesn't check the, that is, while you write the program from 0 to 2, okay, it will print whatever the values that are present here. Okay, if I write the program from 0 to 3, even though 3 is not part of your this particular array, there is a memory here and it will contain some garbage value. It will contain some garbage value. So if I write the program somewhat wrong, the compiler doesn't give you any error and it will print this value also, that is it will print the garbage value 1, 2, 3, 4, 5 as. Okay, so you should understand that your C language or your C compiler doesn't check the array bounds here. Okay, it is the duty of the programmer who is writing to keep check of your bounds while writing your programs. And while writing the program itself, you have to check the bounds, that is where you are starting and where you are ending. If you are making a mistake, okay, the mistake also will creep into your particular program. And if you process that mistake, it will go it as output as some wrong result. So you will be getting wrong results if you don't properly check your bounds here. So in C language, your arrays doesn't check the bounds. It is the duty of the programmer to check the bounds while writing the program. Okay, if you write the program in this manner, you will be getting the output as some wrong result. Okay, so you should be checking these bounds. If you don't check the bounds, you will be getting the wrong result. So while writing the programs using arrays, okay, make sure you start your index from your 0 position, not 1. Okay, you have to start your index from 0 position. So while writing your loops also, I have to start from 0 position and I have to end at n minus 1. Okay, so while writing I less than or equals to, then you have to use equals to means I have to end at 2. Okay, if I just use less than, I can I have to end at 3. So less than means less than or equals to 2. This both are same. Okay, so if you should not make a mistake of writing I less than or equals to 3 or I less than 4. Okay, you should not go beyond these bounds. So you have to make sure you check the bounds while writing the array programs. So this is about bounds checking in arrays. So you will not be having this bounds checking in C language. So this programmer has to take care he is writing the program within the bounds of his array. So this is about your complete description regarding arrays and what are the applications of arrays and an issue about bounds in your arrays. In the next session we will be looking at other topics regarding your arrays and strings. Thank you.